We are going to talk about the specific heat lab and how to do the calculations for the specific heat lab, and then we will maybe even give you some practice problems so that you can prove that you know what you're doing here. Okay, so what's the basic idea of the specific heat lab? You should first make sure that you understand the Q equals MC delta T video that we had prior to this. Okay, so make sure you know how to do those, because otherwise the lab is going to be very confusing. All right, so what are we going to do? Let's assume this is what we did in the lab. We had a beaker, and we're going to put some metal. Now, we're not going to draw little metal pellets. We're going to draw like a block. Okay, we'll just say that there's this big cube, right? Like zinc or brass or copper. And inside that, we're going to have, outside of that rather, we're going to have water. Okay, on the hot plate. Okay, so here's the hot plate for you, and we'll make it nice. Okay, so there's your hot plate, and there's your temperature and so on. Okay, so there's your hot plate. Okay, what we'll do then is transfer that to a styrofoam cup. And the reason we do that is because they're really good at insulating. And inside the styrofoam cup is going to be some cold water. Okay, but you need to know that because we're going to check out the temperature change from the hot metal to the cold water. Okay, so let's talk about the concepts first. And we'll do that with pink, I guess. Okay, so this metal is going to be sitting in hot water. We're going to say it's 98 degrees Celsius. It's not quite it's boiling, but our thermometer says 98 degrees. Okay, so that's the same temperature as the metal, as long as the metal is in there for a while. So this is the TI of the metal. Tim, I guess. TI of the metal. The TI of the water is going to be 20 degrees Celsius. Now you should read it exactly, but okay, so there's the initial temperature of the water. Okay, we know that the water has a mass, and we're going to say that the mass of the water is 50 grams. We measured 50 milliliters, which is the same as 50 grams, so we know that amount of water. We also know the mass of the metal. We're going to say that it was 180 grams. Okay, so what happens? We transfer, so let's change color. We're going to use orange, I guess. We transfer the metal into the water. Here's your metal. Okay, what happens? Well, the heat from the metal goes into the water, and now the final temperature of both of them, we're going to make it up, is 24 degrees. Now here's how it works. You have to say that the initial temperature of 98 dropped down to 24 degrees. And the initial temperature of the water went up to 24 degrees. So the final temperature for both of them is the same. You really, really need to know that. Okay, so make sure you understand what's going on here. Okay, so let's look at the math. The heat lost by the metal and the heat gained by the cup, the water, equals 0. So what does that mean? Well, let's erase that. Okay, what does that mean? It means just that, the piece of metal, right? So there's your piece of metal, gave off heat, and it was collected by the water, right? So there's the water there. All of this heat went into the water, right? And nothing was lost. No loss. Okay, not to the styrofoam cup, not to the air around, nothing. It just said it went from one place to the other. The way we write that equation is we say the Q of the metal plus the Q of the water equals 0. Okay? Now, when we say the Q of the metal, we say MC delta T. That's how you do heat from the previous video. But let's do this one in yellow. MC delta T, okay, equals 0. But let's make sure we know this is the metal, the metal, the metal. This is water, water, water. Okay? Our whole purpose in this lab is to find that value right there, because we actually know everything else. Okay? And we're going to use, we could try to use a highlighter. I don't know how well that works. Let's see if we get, no. I don't know where the highlighters are, so we're not going to worry about it. Okay? But we know everything else. Okay? So let's take a look at that. We're going to take this equation. I'm going to erase this and get it out of the way. If we were to do this math, okay, and leave this here, I'm going to circle it, square it, whatever. The two other values can go under the yellow. Nope. Let's make sure. Okay, so what we're going to do is M and delta T are going to go under this. Let's hold off. Let's do this. Okay, let's do it this way. We say MC delta T. Let's keep it green. Equals the negative MC delta T. And all of this is the water. And this is all of the metal. Okay? So let's do one more thing. Let's leave specific heat right there. And what we're going to do now is negative MC delta T of the water. And we're going to divide by the mass and the delta T of the metal, right? So there's your metal, water, 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 okay? That will give us the specific heat of the metal. So remember that equation, okay? Because we're going to the next page. What did we say? The specific heat of the metal equals negative MC delta T of the water, and that was over the M and the delta T of the metal. Okay? Now, I may have to bounce back and forth, but let's put our numbers in here, okay? So what do we have? The mass of the water, I believe, was 50 grams. We always know the specific heat of water. You have to memorize that number right there. The temperature change was the final temperature minus the initial. It went up to 24 and it started at 20 degrees Celsius. Don't forget the negative sign right there. The mass of the metal, I told you I'd forget. The mass of the metal was 180 grams and it started at 98 degrees. So this is 180 grams on the bottom. And its TF minus TI is going to be 98 degrees minus 20 degrees Celsius. You can pause if you like, but you should try to do this math on your own, okay? So 50 times 4.18 times 4 equals, so we're going to say 836 on the top, and then 180 times 78 equals 14040. That seems pretty high. And I get a number of 0.059 joules per gram degree Celsius. That's really low in terms of what metals really do. But okay, that works. Okay, that works. That's how you find the specific heat of a metal. But I think we should do it again, because that's how we do the whole lab. And so let's make another one. this time we're going to take something like brass. Like brass is more of a brownish color. Okay, I'm sure that matters to you. Okay, so here's a piece of mass bronze or brass or something like that. Let's say that this one weighs 110 grams. We put it in a styrofoam cup. So there's a nice little styrofoam cup. Okay, put the water in there. We will say that again, this time we have 100 grams of water. Okay, and then the temperature of the water is initially, that's messy, so we're not going to do it. The initial temperature of the water is 21 degrees, 21.3. And we put the metal in there, and the metal started out as Ti. Let's say it did reach 100 degrees Celsius. It should be that. Okay? When you put the metal in there, the final temperature of the mixture is, let's say, 31.6 degrees Celsius. Okay? So basically the water went up and the metal went down. And this is where they meet in the middle. There's no way I'm going to remember those, so I have to come back. Okay. But you should learn how to do this. The heat of the metal plus the heat of the water equals 0. And then mc delta T of the metal plus mc delta T of the water equals 0 because no heat is lost. We are trying to find that. So when we rearrange the equation now, we're going to say that we have negative mc delta T on this side, and then we're going to divide by that and that. So we have the mass of the metal and the temperature change of the metal. And that is going to tell us the specific heat of our metal. Let's see what we get here. Okay, so we got to go back. The negative and the mass of the water, that I remember, 100 grams. Specific heat, always 4.18. Temperature change went from, now the final, 31.6 minus 21.3. It should say degrees Celsius, but I don't have room. The mass of the metal was 110 grams. So let's do that. And then the temperature change of the metal. Its final temperature was 31.6. And it started at 100 degrees Celsius. So you see what happens. This negative sign there, that negative sign there will cancel. Okay? So you should try this and calculate this all by yourself. But here's what we do. I like to go over here. Since I have to do that in parentheses, do that first without parentheses. 31.6 minus 21.3. That gives me 10.3. Then you just multiply times 4.18 times 100. And that gives you 4305.4. And then you do the bottom one the same way. 31.6 minus 100. Now that's a negative number. Times 110 gives you negative 7524. And when you finish, it gives you a more reasonable number of 0.572. That's joules per gram degree Celsius. Okay, so you should be able to practice that. Go back and do the other two. I'll give you credit for that. Okay, so let's do some practice problems. Okay, practice problem A. We're going to use a 97.3 gram piece of metal in, we'll always keep the numbers normal, 100 grams of H2O. And the temperature of the water starts at, this time, 19.7 degrees Celsius. The initial temperature of the metal is going to be 98.2 degrees Celsius. And then we'll just make it easier and say the final temperature for both of them is going to be 26.9 degrees Celsius. Okay, and the question for you is, what is the specific heat? Find the specific heat of the metal. Let's do one more. Okay, in this case, we're going to take 107.6 grams of metal in 110 grams of water, just to mix it up a little bit. We'll say that the temperature of the water was pretty cold because it was a Monday morning, 15.3 degrees Celsius. And we'll say that the temperature, oops, not the final, the temperature of the metal initially was 96.2 degrees Celsius, okay? And then we will say together, when they got done, it was 21.0 degrees Celsius. And the question is, what is the specific heat of this metal? Okay, so practice those. Make sure you spell everything out like we did in the video.